Precalc 7.2, we're going to start this today. This one, guys, is the sum and the difference formulas for sine, cosine, and tangent. Now, notice that on sine and cosine, they're nice little formulas. And then tangent is still a formula, but it's a little bit different. But what you do or should notice is that sine keeps its sign, where cosine, we'll say, is the cosine or the opposite sign.
What?
Exactly what I said. So, look here. What we're going to talk about is the sum of two angles. Now, I understand that they're using S and T. You can use A and B, X and Y. It doesn't matter, okay? This is what the book's using. This is what we're going to go with. But if I add two angles, now, what you don't want to use is like theta 1 and theta 2. That's the easiest way to mess things up. But they stand for any angle, radians or degrees, and it says that if I have sine of two angles added together, it's sine S cosine T plus cosine T sine T. Cosine, 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 sine. And then, if there's a difference or subtraction, it's sine S cosine T minus. It's the opposite sign. Or the same sign, sorry. Wow. Ooh. Sine keeps the sign. That's what I'm trying to say. So if you're adding the angles, wow. This video is going to be pretty great.
You're recording?
I'm recording right now.
I'm sorry.
Start over.
And the sign between the trig functions follows what the sign between the angle is. But when we get to cosine, it's the opposite to that effect. So when you're adding the two angles inside cosine, you're actually subtracting the trig functions. And cosine is one of those ones that goes cosine, cosine, sine. Sine. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. There you go. There's a video. You can all look at that video. This is for adding and subtracting angles within a trig function. And tangent, guys, tangent switches on top and bottom. The top follows what's going on between the angles and then switches to the bottom. So tangent S plus tangent T divided by 1 minus tangent S tangent T. We're going to use this two different ways, guys. We're going to start with an angle we don't know, and we're going to convert it so we can use the expanded version. But then we're also going to give the expanded version and have you write it in the combined, simplified version so you can evaluate. So, how we're going to do this first is we're going to start with angles that are not on our unit circle. And we're going to say, hey, wait a minute, 75 degrees? Can I make that up of angles I do know? And the answer is, in this case, yes. Woo! We're going to do this in two different ways. We're going to use the addition property for cosine, and we'll use the subtraction property. The addition property, what two angles added together will give me 75. There's multiple combinations. So it's cosine of 45 plus 30. Would you guys agree with this? Okay. What if I felt like I was doing really well, or I was told, no, you can't use the addition, you actually have to use the subtraction.
Oh, no.
What two angles?
90 minus 30 over 2.
What's that?
90 minus 30 over 2.
90 minus 30 over 2. Well, here's the thing. 30 over 2 is 15. We're going to do that one later. But you just still leaves us 15, and I can't do 15.
Well, could you take the cosine of 30 and divide that by 2?
No, I don't think it works that way. You can't take the cosine of a ratio and divide it by 2. It doesn't work. Think of it this way. This is why. What's the cosine of of 60?
One half.
It's 1/2. What's half of 1/2? 1/4. Is that the same thing as cosine of 30?
No.
No. So therefore, you can't do that. Guys, what two angles when subtracted? And it can be any two angles you want.
100.
It has to be on your unit circle though. 120 minus 45.
Sure.
Does that work? They give you 75?
Yes. Sure.
Okay. So let's expand both of these. Cosine always switches the sign in the middle. And so it becomes cosine 45 cosine of 30 minus sine of 45 sine of 30. Can you guys evaluate that? I would think so, right? Doing the second one, isn't that the cosine of 120? Cosine 45 plus sine of 120? Sine of 45? Could you evaluate that one? I would hope so. So let's go back to the first one. What's the cosine of 45? Square root of 2 over 2. Cosine of 30? Square root of 3 over 2. Sine of 45. Sine of 30. Hey, look at this. Oh, I forgot my sign between them. They all have 2's in the bottom.
Yep.
Or it's 2 times 2 and 2 times 2, which makes a common denominator of 4. So we know our answer is going to have a common denominator of 4. Square root of 2 times square root of 3 minus square root of 2. That's the exact answer. Can you combine the top anymore? No. No radians. This answer has no radians in it. So does everybody understand that square root of 6 minus square root of 2 all over 4 is the exact answer for the cosine of 75? That was the first way. The second way, we did the subtraction instead. So we do the exact same thing. But on this particular problem, I think you guys should understand that sines and cosines are square root of 2's over 2's. That's the easy stuff. But what's the cosine of 120? Cosine of 120 is in which quadrant? 2, which is negative, which has a reference angle of 60. And what's the cosine of 60? So it's a negative 1/2, right? What's the sine of 120? Second quadrant, sine is positive. Reference angle of 60, sine of 60 is? No. Square root of 3 over 2. Hey, wait a minute. Isn't that the same thing as negative square root of 2 plus the square root of 6 all over 4? Is that not the exact same thing we found above? It's just the order is different. Okay? So that proves that both ways will work. There's any combination to get 75. So technically, we could have done 225 minus 150, right? That would work. A couple different things you could do. Okay. The next one's in radians. I want you guys to use radians. I think we all could take 180, throw it in for pi, divided by 12. We understand this is 15 degrees. But if that's helpful, maybe do that on the side. But I still want you guys to kind of go through the work of making sure that you guys can work with radians. Radians is a naturally occurring thing in our world. We made up degrees. Okay? So the question is, how can I split up pi over 12 into pi's over 2's, pi's pi's over 3's, pi's over 4, pi's over 6's. So this is what I suggest. I suggest you write those down. Pi over 2, pi over 3, pi over 4, pi over 6. Those are the ones that are on your unit circle, yes? Now, to make a pi over 12, you need to have a common denominator of 12. So I would go back and make that happen. 12 over 12, yes? 6 over 6. 4 over 4. 3 over 3. 2 over 2. Notice that they're all multiplied. I left that multiplication symbol out. But you know all of the denominators are now what? 12. And the tops reflect how many pi's you have of 12s. So here's the cool thing. There's a couple different ways. There's a couple different ways to get a pi over 12 from those angles. What's one of them? 4 minus 3, or 4 pi minus 3 pi. So let's go with it. So the cosine of 4 pi over, not 3, but 12, minus 3 pi over 12. If I did that, would you guys get 1 pi over 12? But here's the cool thing. I don't want to work in 12, so I want to reduce those now. What is 4 pi over 12? Pi over 3 minus. And now you can use the cosine formula for subtraction. Cosine pi over 3 cosine pi over 4 plus sine of pi over 3 sine pi over 4. And then, is it any different than what we just did? Here's the thing about this, guys. Sines, cosines, and tangents seem to repeat themselves quite often around the unit circle. Would you not agree?
Yep.
So when we get our answer, it's going to look really close to one of those other answers, is because all we're doing is going up to 1 and back down to -1 and back and around and around and around, at least for sines and cosines. Tangents, you have a little bit more free will on there, right? Because it kind of goes, it can be a lot bigger numbers. But we should know the cosine of pi over 3. That's a half. Square root of 2 over 2. Plus sine of pi over 3. Oh, that's square root of 3 over 2. And square root of 2 over 2. Oh, well, that's interesting. That's square root of 2 plus square root of 6 all over 4. Very interesting. So a lot of our problems are going to be pretty close to the same. It's just there's a negative sign someplace that's going to change it. Pretty cool?
Pretty cool.
So the last problem that I want to highlight here is, if I give you the expanded form, can you give me the condensed form so that therefore you can simplify it or evaluate? Notice that we have not touched a calculator on any of this. So you need to recognize, hey, sine, cosine, cosine, sine is for which one? Is that a sine or a cosine or a tangent?
Sine.
It's a sine. Now sine keeps its sine, so it must be 20 plus 40, which is sine of 60. And sine of 60 is?
Square root of 3 over 2.
Done. So just make sure you know what form you're using and you use it correctly. Worksheet number 3, the front side can be done. I do realize, I think on one of the problems for the condensing side, I think it's the cosine, it's a cosine one on the bottom with 80 and 10. You end up creating something when simplified to a single term that you can't evaluate because it's not on your unit circle the way it is. So I'm wondering if I threw either the wrong numbers into there or if I used the wrong formula when I started to write that. So just be mindful. Otherwise, have a great day. Do the pancake run.